Let's talk a bit about direct proportion and inverse proportion. Now, when you talk about direct proportion, you're talking about two quantities that increase together or decrease together. That means when one of them increases in magnitude, the other also increases with it. So in that case, both of them rise together. Or if one decreases, the other also decreases. Both of them fall together. For example, it could be a case where, let's look at an example. Say a car, right, uses 2 liters of gasoline to travel 15 kilometers. How many liters would it use to travel, let's say, 23 kilometers? All right. Now, when you look at that situation, you can tell that it's going to be a direct proportion, because after all, the further any car travels, the more gasoline it will use. So let's do a little calculation with this. It could be a case where you say 2 liters for 15 kilometers. You don't know how many liters. For the 23 kilometers, so you say X liters equal. X liters equal. Now, in the first case, you had 2 liters, and it must be multiplied by a ratio, a fraction. You must then compare kilometer to kilometer, because if you had doubled the kilometers from 15 to 30, you would double the liter from 2 to 4. So what you would have had is 2 times 30 over 15. And 30 over 15 is 2. 2 2 is 4. Or if you tripled the kilometer from 15 to 45, you would have tripled the gas from 2 to 6, because you would have 45 over 15 multiplied by 2. So by the same argument, just like how this is the second journey over the first journey multiplied by the 2 liter, this would be the second journey, 23 over 15 multiplied by the 2 liters. Right? You would know that it could not be 2 times 15 over 23. It couldn't be 2 times 15 kilometer over 23 kilometer, because this value is less than 1, so it will decrease the 2 downward. It will push the 2 downward. And you know that you're not supposed to get a value smaller than 2. It's supposed to be more. The further you drive, the more gasoline you burn. Alright, so in this case, the X liter, whatever it is going to be 2 times 23 over 15. Let's just do it quickly with our calculator. 2 by 23 over 15. Our calculator here. 2 times 23 equal divided by 15, and you get 3.07. So what you have is 3.07 liters of gasoline. Right? So that's one example. So you have several other examples where one quantity increase, you would reasonably expect the other quantity to also increase. Right? So those are called direct proportion. Let's look at inverse proportion. When you're talking about inverse proportion, you're looking at a case where when one quantity increase in value, it causes the other to decrease. Or when one decrease, the other increase. When one quantity decrease in value, the other increase. Alright? Well, the one doesn't necessarily cause the other. It could have some effect on some third quantity which cause the other quantity to increase. But basically, with inverse proportion, when one quantity increases, the other decreases. Alright? Now, an example of inverse proportion. And when you get these examples of inverse and or direct proportion, you're not necessarily told whether it is an inverse or a direct proportion. You just have to think about the scenario and the situation. Right? Say, for example, let me put this example here. Let's say a 1 acre field takes three cutters. They're using these weed whackers to cut the grass. It takes 3 cutters 5 hours to cut all the grass. All right? Question. All right. How many hours would it take? Say 4 cutters. All right. How many hours would it take 4 cutters to cut the grass? Now, you can see what's happening here. The more persons with weed whackers you get, could be weed whackers, maybe they use machetes to cut some of the larger shrubs, whatever the case is. The more of them you get to cut the same amount of land, the same size field, the quicker they will finish, the shorter the time they will have to work. So that's an inverse proportion. You increase the number of cutters, you decrease the time. Alright? So, in this case, you say how many hours? Call it X hours. You don't know how many hours that is. Equal. The X hours after you make the decision. Don't know why my hours look like this. Let me. Alright. X hours is equal to, you're going to do something with the first hour, the 5 hours multiplied by. Now, the answer should give you a smaller number of hours than 5. You cannot put the 4 cutters over 3 cutters because that will give you a larger value than 5. You would say 5 4s 20 and 20 over 3 would be 6 and 2/3. It cannot be more than 5, so something would be wrong with that. You can't do this. So immediately you would know that what you should do is put the 3 over the 4, because here 3 quarters multiplied by 5 would give you a value smaller than 5. Alright? So the 5 hours, I'm doing the calculation, 5 3s 15 over 4. 15 over 4 is what? 4 3s 12, 13, 14, 15 and 3/4. 3 and 3/4 hours, which would be what? 3 hours. What is 3/4 hours? 3/4 of 60 is what? That's 3 over 2 times 30. Right, 3 hours 45. Right, 3/4 hours, that's 45 minutes. It would take 3 hours 45 minutes. Alright? So this could be a question that you apply in project management, right? You want to complete the cutting within a certain time so that it's finished in time for an event to start. So you can calculate how many cutters you need. So you don't hire too many cutters and pay them too much money. They would finish in time, yes, but you could have hired even less additional cutters, and they finish just in time for that event, whatever time it would start. But that's an example of an inverse proportion. Inverse proportion, another example could be speed and time. The faster the vehicle travels, the less time. You increase the speed, you decrease the time, the amount of time it would take, right? A direct proportion could be, like in this case, the amount of gas, or it could be how much flour you would use in a recipe for that number of customers. When the number of customers increase, you have to use even more flour. Or how much rice you would need to cook for a certain number of customers. At the next event you have more, so you increase the amount of rice that you cook, right? That's a direct proportion. So the inverse proportion, this is one case. We're dealing with inverse proportion, right? So these are just a few examples of direct and inverse proportion. So if you want me to do additional examples, just make a comment about that and tell me what it is that you would want me, which question you would want me to work out. All right, but I'll see you in the next video. We'll do additional examples later on.